Hello, everyone. Thank you for joining us today. My name is Tegan Clary, and I'm the Vice President of Marketing at Unchained Labs. I'll be your moderator, and I'm very glad you decided to join us today. Before we get the seminar started, I just want to let any of our customers on this seminar today, or that might be watching this on demand later, that Unchained Labs is dedicated to supporting our customers through this challenging time. If you need something and think we can help, please do not hesitate to get in touch with your local salesperson, application scientist, one of our service engineers, or you can contact us directly at our website. We're ready to do anything we can to help you. We will have a Q&A session at the end of the presentation today. To ask questions, all you need to do is click on the Q&A, the little Q&A button in the Zoom navigation bar. It should be towards the bottom of your screen. Type in your question, and we'll get to as many of them as we can. You will see Anna, our speaker today, pop up on video with me at the end, and we'll be doing Q&A live. And now I'd like to introduce Anna Wenchowska, one of our stellar application scientists. Today, Anna will talk to us about how the Lunatic and Stunner platforms can change your world when it comes to accurate and rapid measurements of protein concentration and dynamic light scattering parameters. And now I'll hand it over to Anna.
Welcome everyone, and thank you for attending this webinar. Today I'm excited to talk about two of our products, Lunatic and Stunner, which can help speed up your DNA and protein quantification, quality checks, and stability testing. As many of us have experienced, one of the major bottlenecks in protein or genomics labs is the volume of samples that need to be analyzed in very limited timescales. For example, in areas like protein purification, characterization, and formulations development, sample concentration and quality checks are required at every step of the process and need to be fast and accurate. They need to integrate seamlessly with our workflow and require minimal manual data handling. To help with quick UV-Vis sample quantification, Unchained Labs offers the Lunatic platform that accurately measures concentrations of up to 250 mg per ml of protein with no dilutions and no dyes required, and with as little as 2 microliters of sample per measurement. Big Lunatic, that you can see on the left, uses a plate-based format and measures up to 96 samples in as little as 5 minutes. Little Lunatic on the right uses a cheap format consumable and is ideal for labs that require lower throughput. Now, Big Lunatic can accurately measure absorbance of 96 samples at a time with only 2 microliters of sample volume required. And the reason this is possible is because Lunatic uses a fixed path-length dual microcuvette system built into the low absorbance plastic strips, which are mounted onto the plate. This unique microfluidic circuit ensures that there is no cross-contamination or evaporation, so you can leave the samples unattended until you are ready to perform the measurements up to 2 hours later. In addition, Big Lunatic plates have the same dimensions as standard 96-well plates, so they can easily be integrated with liquid handlers and other lab automation systems. The optical path lengths of the 2 microcuvettes are 0.1 and 0.7 millimeters, and this allows you to measure a wide range of absorbances from 0.03 to 275 OD. And because the path lengths are fixed, this also ensures high precision and accuracy of the measurement. Now, the wide dynamic range of absorbances translates into a broad range of sample concentrations that can be measured. And to give you an example, the Lunatic can measure protein concentrations from 20 micrograms per ml up to 250 milligrams per ml without the need for dilutions or any other sample preparation. Lunatic measures a full UV-Vis absorbance spectrum between 230 nanometers and 750 nanometers. Therefore, you are able to analyze a wide variety of samples, starting from accurate quantification of UV-absorbing proteins and nucleic acids, through to analysis of plasma samples, looking at hemoglobin and bilirubin components, or antibody-drug conjugates, or other biomolecule small molecule complexes. Now, there are over 35 different applications in the Lunatic software, and they are categorized by sample types such as protein or nucleic acids, and each of these groups has the unique sample-specific application set. Classic applications measure concentration using a total absorbance of the analyte at a sample-specific wavelength, for example, 8 to 80 for protein. And we are using here different background corrections such as turbidity or single point. Unmix applications use spectrum deconvolution algorithm and measure protein concentrations in the presence of different contaminants. This is particularly useful for protein samples that originate from, for example, cell lysates, where we have different impurities such as nucleic acids, detergents, or polysaccharides. We can also measure a concentration of labeled proteins or simply generate different types of standard curves such as BCE or Bradford assay. In the nucleic acids application set, you can also quickly choose between classic or deconvolution algorithms for 8 to 60 absorbance. And you can quickly select the most suitable quantification method based on the origin of the nucleic acid sample or the type, such as single or double-stranded DNA, RNA, or oligonucleotides. There are also options to measure labeled DNA or with specific dyes or RNA and to generate the standard curves. The Lunatic software is designed for ease of use and allows for quick and straightforward experimental setup. You can run up to 10 plates within one experiment, and the software allows you to import all the sample set information directly from Excel. You can also run different sample sets with different blanks in one experiment using sample grouping option and store and recall your blanks in the follow-up experiments. Because Lunatic uses a photodiode array detector, the data collection for 96 samples takes only minutes. And once the data collection is completed, the results are displayed automatically in an overview window within the analysis software. This allows you not only to have a quick look at the results, but also to quickly identify any troublesome samples or if anything went wrong during pipetting or sample loading, so we can troubleshoot straight away. All this data can be quickly exported into the location of your choice using the export button, or you can generate a report with user-defined parameters. You can also look at the data in more detail and look at the individual samples or even raw absorbance data prior to any processing. Here we have an example protein spectrum acquired using classic application called protein turbidity, which uses a total absorbance at 8 to 80 nanometers and turbidity correction. Below in the results table you will have displayed measured sample concentration in mix per ml and both the absorbance at 8 to 80 and extinction coefficient that was used. There is also a 8 to 60 to 8 to 80 ratio calculated for a quick assessment of purity of the protein samples from nucleic acids contamination. And all this data is exportable, including graphs, and you can use either a single or multi-export function in the analysis software. In the Unmix applications, Lunatic uses a spectrum deconvolution algorithm where common detergents or salts, such as EDTA, thiocyanate salts, or azide, are recognized as impurities and are subtracted from the absorbance spectrum of the sample to give a more accurate concentration reading. Here we have an example of a DNA spectrum in black that has been deconvoluted into individual components, and we can see that this particular DNA sample has a small protein contamination and some absorbance contribution from buffer components. The Unmix applications will not only find the impurities in your samples, but will give you a more accurate concentration reading compared to if we were using a total absorbance at 8 to 60 nanometers, for example. And this can save a lot of time over other quantification techniques, because in Lunatic, the concentration of complex samples such as DNA originating from blood samples can be measured directly without the need for a fluorescence dye, dilutions, or any other sample preparation. In the Lunatic software, the data processing is done automatically and it only takes seconds. However, the user has a flexibility to recalculate and reanalyze the existing data without the need to rerun the samples. For example, if you collected the data for your protein or DNA samples using a classic application and you now would like to look into possible impurities in those samples, you can just choose a suitable Unmix application and recalculate your data. Or if you need to redefine the entire experiment, for example, reassigning blanks to different wells, regrouping the samples, or change the extinction coefficients, then it's just a matter of a few clicks. Now, these options, together with quick experiment setup, a variety of sample-specific application, and fast data collection, means that you can get your accurate quantification done in no time and with minimal effort. This brings me to one of the newest members of the Unchained family, the Stunner. Stunner is the first and the only platform that combines both UV-Vis for sample concentration and dynamic light scattering for particle sizing and polydispersity. And because DLS is a very sensitive technique that detects very low levels of large aggregates, this makes it a powerful technique in the areas like purification, product and formulations development, and including long-term stability testing. Now, the real power of the Stunner is that it brings both accurate sample quantification options and quality and stability information in the same experiment, saving both the time and material. Stunner also uses a plate-based format measuring up to 96 samples at a time and using only 2 microliters of sample per measurement. And we can obtain both concentration and sizing and aggregation information for 96 samples in only 1 hour. The Stunner analysis software provides both DLS intensity and mass distributions. The intensity-weighted size distribution indicates how many particle populations are present in the sample based on the scattering intensity contribution, essentially giving information about the presence of aggregates. The mass distribution, on the other hand, describes the relative proportion of each population in the sample. And this allows for quick identification of monodispersed or highest quality samples and those where aggregates are already present and whether the relative proportion of aggregates is significant. The data collection of both UV-Vis and DLS for the entire 96 well plate takes only 60 minutes, and the results are displayed automatically in an overview window where we can toggle between absorbance, intensity, and mass distribution data to again quickly identify the best samples or find the troublesome ones. Again, the data can be quickly exported using the export button, or you can generate a report with user-selected parameters using a report function. You can also look at each sample in more detail, and you have full access to the raw data starting from DLS correlation function, individual subbrands in advanced DLS, and raw absorbance spectra for easy troubleshooting. The primary parameters such as sample concentration, average size, peak size, and PDI are reported directly in the results table, and we can also access and export other parameters from DLS and UV-Vis analysis using the report function. Colloidal stability or self-association propensity is one of the primary considerations in, for example, formulation screening and development. And there are 2 parameters that describe colloidal stability that can be obtained using light scattering. These are B22 or second virial coefficient and KD, diffusion interaction parameter. Both parameters describe the interactions between different molecules in a solution, whether they are attractive or repulsive, and we can obtain them by essentially looking at how the sample scatters light as a function of protein concentration. Now, B22 and KD are determined in the Stunner simultaneously, and because the Stunner can measure both concentration and light scattering at the same time using a microvolume plate, it allows for higher throughput, accurate colloidal stability measurement with minimum sample requirement. The plate format and sample grouping option in the Stunner allows for quick experimental setup and relevant buffer subtraction for accurate concentration measurements. And in a typical B22 KD experiment, we prepare the sample in 5 protein concentrations, each in triplicate plus a buffer reference. With a Stunner, we can obtain B22 and KD for 6 samples in as little as 1 hour. Again, the data analysis in this application is automatic, and there is no need for time-consuming manual data extraction or processing. Here you can see a screenshot of the B22KD results window in the analysis software. The results can be toggled between absorbance, B22, or KD graphs, And you can also highlight each sample group or sample or data point directly on the graph to look at its individual DLS or absorbance data. Now, in addition to all the preset applications in Lunatic and Stunner, the users can also design custom applications using the Homebrew function. Homebrew gives you a full flexibility in terms of data collection and processing and output parameters. For example, you can define the type of background correction or extinction coefficient or DLS filter range that should be applied to your data. The Homebrew allows you to create user-defined outputs by generating custom equations. For example, we could generate statistical analysis of your data or create a completely new application, such as, for example, viscosity measurement using DLS. Again, the Homebrew function gives the user full flexibility in the experiment design and parameters of interest. Both Lunatic and Stunner are automation ready, and there are full robot integration options with API or Scylla, and the instruments also have plate tracking with barcodes to ensure traceability. There is also an option for the 21 CFR Part 11 package that includes everything from system and experiment specific audit trails, electronic signatures, and data integrity checks. Now this brings me to accuracy, precision, and data linearity on Big Lunatic and Stunner. Big Lunatic and Stunner quantification is accurate from its lowest to its maximum concentration. This dilution series on human IgG in PBS spans the entire range from 0.2 to 200 mg per ml and was measured in octuplicate on a Big Lunatic in high lunatic plates. We determined the percent error of each sample, and every Big Lunatic measurement was within 2% of the target value. I would like to announce the launch of our new Lunatic and Stunner software version 7.0, which is now available. Within the new software, you can prove Big Lunatic and Stunner accuracy, precision, and linearity using the new fundamentals application and a kit which contains 5 ampoules of aqueous L-tryptophan with independently certified target concentrations. The Fundamentals Check app calculates average concentration, mean recovery, and relative standard deviation versus target concentration for each of the standards. When measured in high lunatic plates, the average concentrations of every standard are within 2% of the target concentrations, and the relative standard deviations are less than or equal to 1% even at the highest concentrations. The software automatically performs data analysis and makes it easy to evaluate Big Lunatic and standard instruments in the field, giving a simple pass-fail report after a run. We also measure the 5 fundamental standards in a common pedestal-based microliter volume spectrophotometer and compare the percent error at each concentration. Big Lunatics and Stunners perform significantly better in both accuracy and precision when measuring the certified tryptophan concentration standards. Big Lunatics percent error was well within 2% margin for all of the certified samples, while the other microvolume spectrometer range from plus to minus 7%. For those labs doing manufacturing, quality assurance, quality control, or who just wants to comply with international standards, Big Lunatic and Stunner now have UV-Vis performance verification. This is available as a service from Unchained Labs and consists of performing 6 tests using 8 sealed 10mm cuvettes of certified reference materials that fit into a custom metal frame. These tests meet the United States Pharmacopoeia and European Pharmacopoeia guidelines for UV-Vis spectrometers and ensure the suitability of UV-Vis on Big Lunatic and Stunner as an analytical tool. The UV-Vis perform verification tests and all necessary calculations are handled automatically by the Lunatic and Stunner version 7.0 software and are available on Big Lunatics and Stunners sold after April 21st, 2020. If you are looking for additional information on the fundamentals or accuracy and precision on Big Lunatic and Stunner, check out our app note, Spot on UV-Vis accuracy with Big Lunatic and Stunner. For more details on performance verification, you can take a look at the tech note on the subject on the Unchained Labs website. And we will also be doing a follow-up webinar on May 14th about how to use Big Lunatic in upstream and downstream protein labs.
Thank you, Anna, for that great presentation. We have some great questions that have already been submitted. For those of you that are on with us today, you can still submit a question by, again, going to the Q&A section of your Zoom navigation bar. Let's go ahead and get started. So, Anna, what kind of calibration does Lunatic and Stunner require, and how often do you have to calibrate these instruments?
Right, so both Lunatic and Stunner need to be calibrated periodically, and we supply a calibration plate with the instrument so the users can do the calibration on their own. Now there are three things that we need to calibrate for in Lunatic and Stunner. First of all, position of the position calibration, and that's basically for the light beam to go to the right place on the plate, wavelength calibration, and the pump calibration. So we use the pump to push the sample through to the cuvettes once the empty cuvette reading has been done. So that's therefore pump calibration. Now the calibration in the Lunatic is done automatically, and once it's completed, we obtain dated calibration reports that are saved in the software so you can easily access it anytime. And we recommend that the calibration is done on a yearly basis and every time the instrument has been moved or transported elsewhere. Now users can also do an OD check using a potassium dichromate, and there's also an app OD check in the software with the pass-fail results as well. And in addition to this, in the Stunner, there is a function on the instrument calibration page that is called the DLS intensity. And for this, we use an intensity standard to get a reference intensity for measurements like B22. And this needs to be done. We recommend it for it to be done every 6 months.
Okay, great, Anna. Anna, you talked a little bit about B22 and KD. And there's a question in here. What's the difference between B22 and KD in the Stunner and on the Uncle system, and which one is better?
Okay, so there are two main differences between Uncle and a Stunner when it comes to B22 and KD measurements. So the first of all, in B22, just a quick reminder, B22 and KD are essentially in the B22 and KD, we are essentially looking at how the sample scatters light as a function of concentration. And because Stunner measures both accurate concentration and DLS within the same experiment, this eliminates the need for to use other techniques for concentration measurements, which obviously saves us time and sample. And secondly, obviously we get more accuracy and less variability in the results. Obviously, Uncle doesn't have the UV-Vis option, and therefore we have to rely on other techniques for concentration measurements. So that's the first difference. The second one is a throughput. In a Stunner is a plate-based system where we can run up to 96 samples at a time. And in a typical B22 KD experiment or setup, we would prepare the protein at 5 concentrations, each in triplicate, and we also have a reference buffer. And this would add up to 16 samples per protein in your formulation, for example, in your formulation. So that means that we can run up to 6 B22 KDs at the time on a Stunner, and that would take around 1 hour. By comparison, in the Uncle, we can run up to 48 samples within one experimental setup, and therefore we would get up to 3 samples at a time, while B22 KD results for up to 3 samples at a time. I mean, that's with the standard setup for B22 and KD. And the last little difference is just simply volume. Stunner uses 2 microliters of sample per measurement, and Uncle requires 5 microliters per measurement. So if you require a higher throughput beta-2-KD with the minimum sample volume and confidence in your concentration measurements, then Stunner probably is the way to go. But Uncle does beta-2 and KD tests as well.
Okay, great, Anna. I think that was a great explanation of the difference between the two. So Anna, is there any sample preparation needed at all for either the Lunatic or the Stunner instruments? Does anybody need to do anything special before they run their samples?
Right now, the simple answer is no. The samples in both Lunatic and Stunner can be measured directly, and there is no need for any dyes, dilutions, or other sample preparation to obtain concentration. So that can be done directly with the sample as it is. The only thing we would recommend to do is to spin a vortex and spin the sample to just make sure that the sample is homogeneous. But other than that, you can measure the concentration directly on both instruments. Now for the DLS measurement, obviously we have to remember that not all samples will be suitable for DLS, and therefore, so if you have, for example, very high content of aggregates or very large aggregates, then we may need to filter the sample beforehand, but that would be on the that would need to be assessed on the case-by-case basis.
Okay, great. Yeah, so it's very simple to use. I know I've used it quite a bit as well. It's just simple, and it's, you know, as long as your samples have been filtered, it's typically drop it, shoot it, get an answer. So Anna, the SBS format or 96 well plate format of the consumables for this instrument and just the workflow, does Unchained Labs have people that are integrating these systems or connecting these systems to automation systems?
Yes, we have actually a lot of users who do integration with all sorts of different robots. Yes, by all means. There are also full integration options like API, for example. We supply a software that can be used for integration. So yes, by all means, a lot of our users actually have the instrument, either Lunatic or Stunner, just connected to the robot, and they can have even higher throughput in their labs.
Okay, great. So Anna, I think this will be our last question for the day out of those that have been submitted. How can we measure viscosity on the Stunner? Is that something we can do?
Yes, we can do viscosity on the Stunner, but we need to use a Homebrew tools for this. Generally with DLS, we can obtain viscosity using a Stochastic-Einstein equation, which basically describes the relationship between the particle size and viscosity. And for this measurement, for the actual measurement, we would use the beads of a known size. Usually they will be like a certified, NIST certified size standard, so that will be polystyrene latex beads. And we would look at how that size changes, the size of the particle changes as we add them to an unknown viscosity sample. And therefore, because we know what the size should be, we know what we get, we can back calculate the viscosity of the measured sample.
Okay, very cool. So, hey, Anna, thank you very much for answering all these great questions, and thanks for a great presentation today. I also want to thank all of you who have joined us live today. With many of us working remotely, I think this is a really great time to explore new tools, new ideas, and look for new solutions to problems. If you'd like to have a deeper conversation with our team about Lunatic or Stunner, please do get in touch with us. Our team would love to connect with you over a Zoom meeting just like this, but more interactive, where we can talk to each other. And we'd also be happy to set up a virtual demo if you'd like to take a closer look at one of our instruments. I know Anna has an instrument at her home that she'd be happy to show you if that's something you're interested in. Our labs are also up and running, and we can also do demos of some of our other instruments that are not necessarily as easy or as portable. We do have quite a few other virtual seminars coming up, as Anna mentioned. There's also a bunch of on-demand webinars. Anna has done one recently just a couple weeks ago. You can see all of those in our events section on our website at www.unchainedlabs.com. So take a look at those when you get a chance. And with that, thank you for attending this virtual seminar, and I hope you have a great rest of your day.